So you should be able to see my slides. Okay, so today I'm doing element compound mixture revision. All right, as usual, if there's anything you don't understand, please type into the chat. All right, or you can unmute yourself. Okay. All right. First question, the concept that this question is trying to test you, right, is actually in the yellow box. I type it out for you. So what you need to know is, all right, most metals, I say most, not all. There's always some special cases. All right. So most metals are good conductors of heat, good conductors of electricity. Most metals have high melting point, high boiling point. All right. Now, can y'all tell me, okay, what is the meaning of high melting point? Can y'all type in the chat, high melting point, what is your understanding? If you need to go toilet, if you need to go and get your water, go ahead. All right. Don't need to ask me for permission. Just type into the chat. At least I know. And then if you're back, just say I'm back. All right. So going toilet, getting water, go ahead and just come back quickly. Okay. All right. So LeBron, go ahead. Thank you. So what is the meaning of high melting point? Anyone? Please type, everyone, please type into the chat. What is your understanding of a substance having high melting point? Okay, what's the meaning of high melting point? Anyone? Okay, let me ask, maybe we ask Hei Ying. Hei Ying, would you like to try? If I say a substance has a high melting point, what does it mean? Okay, they must reach, thank you for your response, Hei Ying, in the chat. They have to reach a very higher temperature to melt. Very good. So in other words, you need to heat until the temperature is very, very high. Then it starts to melt from solid state to liquid state. Melting is solid, change to liquid. All right, so metals quite hard to melt. You need to heat to quite a high temperature. All right, and quite hard to boil. Except for group 1 metals. Group 1 metals are the special cases. All right. So group 1 will be lithium metal, lithium, sodium, potassium. All right. Lithium, sodium, potassium are the special cases. They have low melting, low boiling point. So group 1 metal, special case. Then most metals have high density. Now, what do I mean by high density? So for example, let's take a look here. Now, this one, 0.96. All right, it's considered high density. Do you think it will float on water or sink in water? Float or sink? Can everybody type in the chat or you unmute yourself? Float. Will substance D float or sink in water? Looking at the density. All right. Good, Vidu. Thank you for your response. The rest, please give me the response so that we can go faster. I want to play games later. Right? So now, do you all know what is the density? Okay. Some of you say float, some of you say sink. All right. Now, when you give me the response, at least I know what are the misconceptions that some of you have. Don't worry, I will not get angry if you give me wrong answer. I will only get upset if you don't respond. So please respond. I'll appreciate it very much. Then over here, do you know what is the density of water? Anyone? Or type into the chat. What is the density of water? So I'm going to write it here. Density of water. Thank you, LeBron. Thank you, Vidu. Density of water. All right. It's a number that you first learn when you are in kindergarten. The first number you learn is 1, right? Okay. It's 1 gram per cm cube. All right. Every 1 cm cube of water will weigh 1 gram. So this is the density. Now, any substance more than 1, so 8.96 is more than 1. All right. So it's more than 1. More than density of water. Therefore, you expect it to sink. So D will sink in water. Is everybody clear? All right. Now looking at ABCD, can you tell me which substance will float on water? Please type into the chat. ABCD, which one will float on water? Thank you, Vidu. Good job. The rest, which one will float on water? ABCD, which one will float on water? Okay, good job, LeBron. I only have Vidu and LeBron. I got so many students in my class. Hei Ying, which one will ABCD? Which one will float on water? All right. Okay, good. So look at this number, 0.97. This is the density. All right. It is less than 1. All right. So it's less than 1. It's less than the density of water. Right. Density of water is 1. Right. Which is 1. right? Therefore, substance C will float on water. So as long as the density less than 1, it will float. Density more than 1, it will sink. Is everyone clear? All right. So in other words, the rest, I'll just write down sink. Right? I'm talking about water. Okay. Then if you look at this, then so you want something that's good conductors of heat and electricity. So good, you put a tick. All right. If it's high melting point, boiling point, now these two are negative numbers, is considered low. Anything more than 500 and above is considered high. All right. So high melting point, metals can conduct electricity very well. And then metals usually will sink, all right, in water. So I put the tick for metals. Okay, therefore the answer for this question is D. All right, is everybody clear? So for this question, please know that most metals, melting point will be very high. You need to heat to a very, very high temperature in order to melt solid metal into liquid metal. All right, so imagine you have solid iron. You want to melt it into a liquid iron. All right, then you need a very high temperature. Okay, very high temperature in order to melt. All right, high temperature to melt. Okay, to melt iron from solid state to liquid state. All right, so this part, hang on. Okay, this is just an extra point. Okay, solid iron melt to liquid iron needs a high temperature. All right, let's move on. Okay, maybe I'll just let you know, group 1 metals are special cases. So for example, lithium, sodium, potassium. All right, some of them actually float on water. Can you imagine a metal that float on water? So these are special cases. Special case. They actually float on water and it's very easy to melt them. Okay, special cases. Some of them are you put in your hands, the metal will melt into liquid metal. You just need your body temperature, you'll melt it already. You don't even need to heat up 500-600 degrees Celsius. So lithium, sodium, potassium, all the group 1 metals are special cases. They have low melting, low boiling point. They have low density. They float on water. Can you imagine? Lithium, sodium float on water. Lithium, sodium metal float on water. And lithium, sodium is easy to melt it from solid state to liquid state. So group 1 special cases. Other than group 1, most of the metals have high melting boiling point. All right, any questions so far? If not, we go on to question 2. All right, so pure metals. Right, so now, you know what are metals, right? Let's take a look at this. Now, do you see this word elements? So everything that you see in the periodic table, they are elements. They are not compound, they are not mixture, they are elements. All right, now who can help me draw the staircase, my beautiful staircase? Annotate on my slide, please. Anyone? Quickly, the first person. Help me annotate to separate metals from non-metals. Can I have a volunteer, please? Thank you very much, LeBron. All right. Okay, I will need LeBron to erase it. Otherwise, you know what happens? You see, next slide will all have your annotation. That's the black part. All right. Thank you, LeBron. At least I know you all know what I'm talking about. So I just use a highlighter using red. So vertical line, horizontal, vertical, horizontal, vertical, horizontal, vertical, horizontal, vertical, horizontal. You draw it on your own. Then just take note, hydrogen belongs here. All right. So left-hand side is all the metals. Right-hand side is all the non-metals. All right. So hydrogen is a non-metal. So on the right-hand side is non-metal, left-hand side is metal, and all of them are elements. And how do you know they are all elements? If you notice, right, all of them have only one capital letter. All right. They only have one capital letter. So for example, capital N, small letter E. All right. Capital Z, small letter N, all one capital letter. Okay. So going back to that question, so pure metals, obviously they are elements. So in fact, please know that metals are elements. How about non-metals? Are non-metals also elements? Yes or no? Come, someone type into the chat. Are non-metals elements as well? I'm talking about non-metals. Thank you, Vidu. All right, so I don't care whether it's metals or non-metals, they are all elements. All right, take note. Okay, from the periodic table, I already said everything is element. All right, so they are pure metals are not compounds. Pure metals conduct electricity. So the answer is 1 and 3. So answer is B. All right, any questions so far? Let's move on. If you have questions, stop me. Then this one talking about periodic table. Elements change from left to right. We all know they change from metals to non-metals. All right, I explained that in the periodic table here already. Let's move on. Next question, some of you, now do take note, not all of you have submitted the online homework. All right, so like for example, students like Eldia, very good. All right, model student, he actually submitted 2 times. That means he submitted once, he knows where his mistakes are, and then he thinks over he thinks about why he got it wrong, and then he attempted the same quiz again online, and then he got all correct. All right, so please at least submit it once, right? If you don't have time to resubmit, at least submit it once. Some of you have not even submitted it. All right, so if you submit it, at least I'll know what are the common errors, all right, common mistakes that most of you have, then I can address it during the tutorial. All right, let's go to aluminium. So aluminium is capital A, small letter L is over here. All right, so you can see that, now first of all, you must know this is group. Group is vertical. All right, maybe I'll write it on top. So this is group. Then period is across. Oh, Vidu, you did it 2 times at 8:30. Thank you very much. All right. Okay, well done. Sometimes if I see it yesterday, that I may not see if it's early morning lah. Okay. So group and period aluminium, right? So group is group 3. So you should write this way. All right, Roman numbers. Then period, take note, period. This is period 1. All right, period 2 and period 3. So you write 3 this way. So actually it should be like that lah. Right, so the answer is C. Okay, any questions so far? Right, so group number. Okay, so group is like that. So group 3. Okay, then I change to the color period. This is all on period. Okay, this is period. So it is period 3. Right, I color code it. All right. Question 5, you watched a video just now. Those of you who came in earlier, you watched a video on loop repeatedly, right? So you have a teaspoon of sugar heated strongly. So at first, take note, if you have a solid sugar, you heat it up in the first few seconds, it will simply becomes liquid sugar. So can everybody name the process? What process has taken place? Put into the chat. What process has taken place to change from solid state to liquid state? Thank you very much, Vidu. Good job. The rest, what has happened? Good job, Hein. All right, what has taken place to change from solid state to liquid state? So LeBron, good. It is a melting process. So I heat to melt it. All right, heat to melt sugar. And then this melting is a physical process. All right, so this is a physical change. Right, or physical. All right, it's a physical change. Physical means nothing new, no new substance formed. Right, no new substance is formed. All right, because sugar is still sugar. Solid sugar, liquid sugar, they are still sugar. All right, but over here, if you keep on heating it, all right, so this is sugar. There are many different types of sugar. Here is sucrose. Right, so if you are interested, we have, the sugar name is very cute, all right? Glucose, sucrose, lactose, galactose, maltose, all have OSE. All right, glucose is 6-12-6. All right, you need to remember this number, 6-12-6. It sounds like 6 times label. 6-12-18, but instead of 6-12-18, it's 6-12-6. Then sucrose will be C12H22O11. It's a bigger molecule. 12 carbon atoms, 22 hydrogen atoms, 11 oxygen atoms. So this is sucrose. You heat it up, you get carbon. Can someone tell me what is this? Is this water? Type into the chat. Is this water? H2O.